From the Southeast Asian capital city of the Philippine Islands, the Philippine nation, Manila, good morning, good afternoon, good evening, whatever the case may be, wherever you are in the world. And for most of you from the other side of the world, I bid you good morning, good afternoon, evening, and all the rest of that. I'm Art Bell, filling in for George Noory, who's taking the evening off. Bless his heart, he can certainly use it. All right, well, listen, everybody. All the ABs are well. In fact, the ABs took the opportunity. I rarely go to the movies. You know, I'm a stay-at-home and watch movies at home kind of person. But I had to see it. Avatar is... I went to see Avatar at IMAX here in Manila in 3D. And, oh, my God, it was gorgeous. What a, in every sense of the word, gorgeous movie. I think it's now, unless I'm wrong, and I could be, but I'm pretty sure it's now the biggest grossing movie of all time, and deservedly so. It was an experience, and I wonder if our world can ever be as it is was in Avatar. I guess not. But it's impossible to go to that motion picture without thinking, maybe somewhere we went wrong, and it should have been like that, but it's like this. I don't know. Anyway, if you get the opportunity to see it, that's one movie you really should not watch at home. You should go to IMAX if you have one, or at least a 3D theater, and see it in 3D. The 3D was not overdone. It's not like the old days where ping-pong balls came out of the screen and hit you in the nose or went over your head, whatever. You know, it's not overdone. It's just done tastefully. And, of course, the story itself, even if it wasn't in 3D, is superb. So, what can I say? Recommend it to all. Avatar. If you look on the website, young Miss Asia is there in all her glory, and she is really getting to be gorgeous. There's a picture of her on the front page of the coasttocoastam.com website. And if you click on more, you'll get more. You'll get a bigger photograph of Miss Asia, who is doing really well. She's just talking up a storm, everybody. Unless you put a microphone or a telephone in front of her, and then she won't say a word. Well, there's some pretty big news. As you know, I've been working on trying to get a ham radio antenna up here. And it's kind of up. It's halfway up. I actually hired, I went through red tape that you would not believe. You know, through the board of directors. This time I did it all right. Instead of sneaking up there in the middle of the night, which I did in 2006, and put up my own antenna, this time I did it right, and I applied through the board of directors. It went through the National Telecommunications Bureau. It went through everybody you can imagine, and it's sort of halfway up there now. They're painting our building. So when they get on painting the building, I can put the larger wire antenna that I'm lusting for up. But right now I've got something for 2 meters and 440 already up there at about 215 feet above the city. And let me tell you, it works. It really, really works. So halfway up, and when they finish painting the building, the rest of it will go up. That kind of comprises the personal news. Looking at the national news very quickly, there's a lot of backlash, and so the 9/11 trial may not occur in Manhattan near the site of the attack. There's just too much going on, so it may well be moved out. The venue may be elsewhere, and that's sort of understandable. The president and the GOP had a rather sharp encounter, one not normally seen in American politics, except during a presidential debate or something of that order. But there was a lot of back and forth, just like a presidential debate. Very interesting. Toyota says the new gas pedals are on the way to dealers, and then I guess you. The Haitian tragedy, of course, has occurred since we last talked, and it's awful. At least 150,000 dead, I'm hearing now. And the Haitians are now sick of waiting for somebody to come along and reconstruct, so they're beginning to reconstruct themselves, putting back some homes that were destroyed, starting to rebuild on their own because they have sort of given up that anybody's going to come along and help. Tonight we've got Dr. Michio Kaku coming in a few moments. There's one more. I got, of course, a lot of email about Haiti, and I sat here and I watched all the CNN coverage, like I'm sure the rest of you, after the earthquake. But I've got an email here that I'm going to read it to you. It's sort of about Haiti and more, I guess. In my opinion, it comes from the depths of a truly disturbed mind. But you be the judge. Here it is. Yes, referring to Haiti, this is another staged event by our own shadow government, reminiscent of guiding Katrina into New Orleans with HARP and ocean spot-warming laser satellites, plus then exploding the dikes after a 24-hour wait to see how much damage only the hurricane had wreaked upon the black race. As you know, Prescott and Hitler and the two Bash, meaning Bush, presidents are eugenics enthusiasts. Although the new moon at perigee, passing in front of the sun, together, he says, with retrograde Mercury and Venus passing in back of it, with the massive Jupiter-Neptune conjunction in nearby in Aquarius and retrograde Mars opposing in Leo exerted substantial gravitational destabilization, our shadow government focused the epicenter using Illuminati technology existent for the past half century, plus possible tunnels bored near the island equipped with near-range transmitters. As in the case of 9/11, and the European subway explosions, government military agencies were conducting simultaneous drills to confuse the situation for unaware investigators. Many of the blacks and Mexicans not tortured to death in this, in quotes, natural disaster will be recruited into U.S. police forces for crowd control of American citizens after U.S. martial law is eventually declared due to other staged events. Now, these immigrants make ideal policemen from a New World Order perspective because they really don't like us, can barely communicate with us, and therefore are not nearly so reluctant to taser and shoot us as American cops would be. That is, those not killed by the New World Order fake flu. You wonder about where these things come from. And I get a variety of things, but this was so over the top, so uber, as they say here, that I just couldn't resist reading that to you. I will, to prevent the embarrassment, though I don't suppose there would be any, I will not reveal the name of the person who said that. Dr. Michio Kaku is a theoretical physicist, best-selling author, popularizer of science. He's the co-founder of string field theory, a branch of string theory, and continues Einstein's search to unite the four fundamental forces of nature into one unified theory that may end up, if I recall, perhaps not being any longer than your thumb. That would unite, that would bring together everything. I suppose if that happened, if it really happened, then we would have an avatar kind of place where everything is connected. Anyway, meet Dr. Michio Kaku, Professor Kaku, coming up in a moment. Professor Kaku, welcome back to Coast AM.
Art, glad to be on again after all these years. Glad to hear from you.
It is great to have you, and I would like to note that my wife, who is, as you know, Filipina, without any word from me, about an hour ago, as we were eating breakfast, it is a different time over here, mentioned to me, I saw Dr. Kaku on the Science Fiction Channel. That's my Filipino wife.
Mm-hmm.
So You know, several years ago, you may recall, or maybe not, I mentioned to you that I thought you were well on your way or were on your way to becoming the next Carl Sagan. Remember that?
I remember fine. I remember that well. Yeah?
Yeah, I think it's coming true.
Well, thank you, and I think you had a lot to do with it, Art.
Well, maybe we got it started. I don't know, but boy, you're everywhere. We're lucky. We just got high definition over here in the Philippines. The beginning of it, anyway. We've got the History Channel, we've got the Discovery Channel in HD, and now HBO in HD, and I just see you all over the place.
Well, starting February 5th in the Philippines, Sci-Fi Science, which is my new show that I host every week, will be debuting. So all throughout the Philippines, Malaysia, Hong Kong, you can see Sci-Fi Science, the new show that I host. And, I'm sure a lot of your fans have made it a big success. It's the number one news show on the Science Channel, by the way.
The promos are going like crazy over here, and that's how she saw you.
I see. Oh, also, by the way, if people want to make contact with me, my website is still the same, mkaku.org, mkaku.org. And I'm also on Facebook. So if you want to become a friend, you can become a friend of mine on Facebook on mkaku.org.
Doctor, I'm curious. All your early life, you were a theoretical physicist, and of course still are, but you were sort of in a science world, and now in the last few years, you've kind of moved into the media world. What's that like? What's it like for you?
Well, see, first of all, my anchor is still research. The Large Hadron Collider got turned on last month, thank God, and we're eagerly awaiting the results of it, which will come out in a few months, and, that's what I do for a living. We hope to test string theory with the Large Hadron Collider. It's not going to eat up the Earth, so don't worry about the Large Hadron Collider. But, that's what I do for a living. But, I also want to share with the world the enormous excitement that we physicists feel as we find new planets in outer space that are becoming more and more like the Earth, as we begin to probe the very center of the atom with the Large Hadron Collider, and as we begin to probe the instant of the Big Bang with our satellites, there is just so much exciting research in science that I really want to help to communicate the enormous discoveries that are being made right before our eyes with our satellites, with our machines. It's a great time to become a scientist.
You, I guess, were familiar with the theory that was bouncing around about the collider that things keep going conveniently, coincidentally wrong with it, and that somebody was sabotaging it from the future because it might eat the world.
Yes, that theory was actually proposed by a colleague of mine, Professor Nielsen. He actually is a reputable physicist. He works on string theory, just like myself, and he's been doing all sorts of cutting-edge research for quite a while, but he's also rather famous for once in a while coming out with the real wacky idea, and that's one of them, that the Large Hadron Collider was jinxed from the future, and the jinx is traveling backwards in time. So we physicists know every once in a while to expect some kind of crazy idea from Professor Nielsen. So this is his latest. However, like I said before, the Large Hadron Collider is operating very smoothly now without any hitch at all. It's working much better than expected, in fact, and we should be getting some real data in a few months from the machine. It's been turned on, they've been testing it, and we hope to get some real data from it later this year, so we're very excited by it.
Okay, but they're not yet out of the testing phase.
Yeah, they're still testing it right now, and as I mentioned, Mother Nature creates particles much more powerful than anything that this pea shooter can create on the Earth. For a human, the Large Hadron Collider looks colossal. But from Mother Nature's point of view, Mother Nature would say, ha, this is a pea shooter. Mother Nature collides black holes in outer space and creates particles much stronger than anything we could possibly create on the planet Earth. And we're still here after billions of years.
How big is the collider? Can you tell me?
Yeah, I've been there. In fact, 3 years ago, I took a film crew from BBC Television, and we actually filmed in the tunnel, and I actually touched the tube itself, which is now, of course, radioactive. The tube is 17 miles in circumference. Wow. It is so big, it straddles the Swiss French border. It's that big. And, people wonder, well, how come the Europeans are building this big machine? Well, we were going to build an even bigger one, 3 times bigger than the Large Hadron Collider. That was the dream of President Ronald Reagan. Ronald Reagan wanted to put the Super Collider outside Dallas, Texas. It was huge. However, because of budget cuts and, cost overruns, it got canceled.
Didn't they actually start work on it?
Yeah, they allocated $1 billion to dig a gigantic hole, and then they canceled it. Congress canceled the machine, and then they gave us a second $1 billion to fill up the hole. That's $2 billion to dig a hole and fill it up. That's Congress for you.
It's America for you.
Yeah.
We dig a hole and then another $1 billion to fill it back up again.
Yeah. And at the last day of hearing, a congressman asked a key question. He said, will we find God with the Super Collider? And the physicist who was asked that question didn't know what to say. So he said, we're going to discover the Higgs boson. So all the jaws hit the floor in Congress, $11 billion for another goddamn subatomic particle. So they canceled the machine. So since then, we physicists have been running through our heads, how should we have answered that question? Will we find God with your machine? I would have answered it by this. I would have said this. I would have said, God, by whatever signs or symbols we ascribe to the deity, this machine will take us as close as humanly possible to his greatest creation, Genesis. This is a Genesis machine. It's a machine designed to probe the mysteries of the greatest event in the history of the universe, its birth.
So, in a sense, we might have or might still discover God or God's work.
In some sense, yes, and that's what Einstein was chasing after. He wanted to, quote, read the mind of God. These are his exact words. And we think that string theory is it. We think that string theory is the theory that Einstein missed, the theory of everything, an equation 1 inch long that would allow us to read all the mysteries of nature, all the equations summed up into one master equation. And that's what the Large Hadron Collider is designed to probe. We hope to be able to probe this and create something called dark matter. And we think that most of the universe is made out of dark matter. And dark matter could be matter from another dimension. So the Large Hadron Collider is actually powerful enough to create dark matter on Earth, not in outer space. And we think that dark matter could be matter hovering just above us in another dimension.
Does that give us any sort of eventual access to another dimension?
Well, we think that gravity does go between universes. Think of 2 parallel sheets of paper. We live on the bottom sheet of paper. And let's say there's a galaxy hovering above us in another sheet of paper. We cannot see it because light passes beneath this other galaxy. So the other galaxy is invisible. But gravity does freely go between these sheets of paper, these 2 parallel sheets of paper. So the galaxy would appear to be massive. It would have gravity, but it's invisible. But that's exactly what dark matter is. Dark matter is more plentiful than ordinary matter. You and me, we are the exceptions. Atoms are the exceptions to the rule. Every high school textbook on Earth is wrong when it says the universe is mainly made out of atoms. That's the old obsolete picture that's now been thrown out the window. Most of the universe is made out of dark matter, and it's invisible. It has gravity. It has weight. You can actually... If you were to hold it in your hand, it would have weight, but it would be invisible. And we think that we can create dark matter with the Large Hadron Collider. That would be incredible. That would shake the foundations of science.
If it has weight, then it has mass?
Yes, it has weight, it has mass, but it has no charge. So therefore, if you were to hold it in your hand, it would be ghost-like. It would actually filter through your hand, through the floor, through the crust of the Earth to China, and then back from China through the crust of the Earth back to America and go back and forth between China and New York City, where I am.
Why?
Now.
Why would it do that? Why wouldn't it just keep going out into space?
Oh, because the gravity field of the Earth would be enough to pull it back, right? So it simply oscillate back and forth from, let's say, New York to Beijing and back again as if the Earth were not there. It would feel the gravity, but it would be ghost-like. It would go right through walls. And we think the Earth is moving in a wind of dark matter. And we think that dark matter is penetrating our bodies even as we speak, just like a ghost, but it's very difficult to detect.
Is the Earth then, in effect, capturing dark matter?
Yeah, we hope to capture dark matter in a bottle. There's several large groups now.
No. I'm asking if the Earth itself is capturing. You said we're sort of in a wind of dark matter,
That's
and
right.
you also said the gravitational field would capture it or hold it. So,
right. If this has low energy, then we would actually capture it in the Earth. That is, there would be dark matter oscillating in the crust of the Earth right now, even as we speak.
But that would add more. We've got a break here. We'll be right back. That would add mass. I've got to think about that during the break. I'm Art Bell with Dr. Michio Kaku. Actually, from the other side of the world, from the great mass of you, it's Southeast Asia, and if my voice sounds a little rough, it's because I'm recovering from another Southeast Asian virus. I'm catching them all, so that eventually my immune system will simply laugh off everything from either side of the world. My guest is Professor Michio Kaku, and here's my theory, just based on what I heard. If dark matter is streaming at us constantly, and some portion of it gets captured by Earth, and dark matter actually has weight and mass, then wouldn't that eventually actually add to the mass of Earth and or other planets and bodies out there? It's a very interesting question. Or maybe it comes at us so quickly that it just goes through Earth and back out into space again. But you would think some of it would be captured and then measurable as additional mass on Earth, perhaps indistinguishable from, the various meteors and so forth that strike Earth. I'll ask about that. We'll be right back. Before we leave the subject of gravity, I want to ask the professor a gravity-like question. But back to dark matter for a second. Professor, how about that? I mean, isn't some of the dark matter perhaps then captured by Earth if it's streaming by all the time, adding to the mass of the planet?
Well, Art, I think you stumbled on one of the great principles of the origin of our universe. It turns out that dark matter clumps. Because it has gravity, it's invisible, but it will clump. And that attracts matter to the center of the clumpiness. And we think that's the origin of the Milky Way galaxy. Believe it or not, when you look at the Milky Way galaxy at night, we think that the entire galaxy condensed as a consequence of the clumpiness of dark matter. So the question is, which came first, matter or dark matter? We think that the clumpiness of dark matter came first. And that attracted matter to form a nucleus, and that nucleus became the Milky Way galaxy. So not just the Earth, you were talking about the Earth, but apply that same principle that you just mentioned to the entire Milky Way galaxy. And if you do computer simulations, you get gorgeous structures that look just like our universe. The clumpiness of galaxies corresponds to the clumpiness of dark matter. So the very fact that you and I are sitting here on the planet Earth is a consequence of the fact that dark matter has clumped in this sector of the universe.
And you really think the Hadron Collider is going to yield up some dark matter?
That's right. That's the hope. Another theory says that it's another higher vibration of the string. We are the lowest vibration, like the lowest octave of tiny little rubber bands vibrating everywhere. All the neutrons and protons are nothing but the lowest octave. But a string can twang. You could have higher octaves of a rubber band, and we think these higher octaves are dark matter. And so we think that the Large Hadron Collider may actually prove the existence of dark matter. String theory predicts what are called sparticles. Sparticles are superparticles, and if you do the math, it works out. We think that dark matter is sparticles. They're the same thing.
Is there any great danger in pursuing this? In other words, Einstein gave us the theory that gave us the atomic bomb.
Mm-hmm.
And once we get dark matter and or figure out how to manipulate dark matter or whatever, is there another bigger atomic bomb in the mix somewhere?
We don't think so. First of all, matter like uranium is stable, and therefore you can create atomic bombs out of it. Most of the subatomic particles that the Large Hadron Collider produces are unstable. They last for a fraction of a second, and they just disappear. Even if they were like tiny microscopic black holes, micro black holes as we call them, they just evaporate so quickly that you can't make anything out of it. Now, dark matter is a little bit different. Dark matter is stable. We think that that's why the Milky Way galaxy is here, because it clumped, because dark matter clumped first, and we came second. However, dark matter you cannot make a bomb out of it because you cannot get enough of it in one place. The density today of dark matter is very, very thin, and it holds the galaxy together. It was the nucleus that created the Milky Way galaxy, in fact, out of dark matter, but it's simply too rare. It's too rarefied to bring it together. So we have no known way of clumping it ourselves other than gravity. You can't build a collector to collect dark matter because dark matter will go right through your collector. It's very ghost-like. It'll just penetrate any object known to science. So that's why dark matter is stable, but is unusable for a bomb.
How does dark matter react with antimatter?
Well, antimatter is simply ordinary matter with the opposite charge. If you watch the movie Angels and Demons with Tom Hanks, you know that matter and antimatter, when they collide, will release vast amounts of energy. It's 100% conversion of matter to energy, and that's why Dan Brown used it as a way to perhaps blow up the Vatican. So that is volatile. However, antimatter is extremely expensive. When I was in high school, years ago, I played with antimatter. I photographed it. I went to the National Science Foundation, National Science Fair in Albuquerque, met Edward Teller, who then became my mentor. And then when I was in high school, I built an atom smasher to try to actually create a beam of antimatter of my own. But antimatter is extremely expensive, and so it would cost trillions of dollars to build a bomb even close to what was in the movie Angels and Demons. So we don't think that an antimatter bomb is practical because it's simply too darn expensive.
Well, our government deals in trillions these days. While we're on the subject of gravity, I have a very good friend, Michael, in Taiwan. He's now in Taiwan. He said, "Hi, Art. I hope you can include some discussion of the nature of gravity in your talk with Professor Kaku. For instance, if we disregard influences like solar wind, passing bodies, and so forth, if we had a metal sphere, I assume there is some point in space between the Earth and the Sun where the opposing gravitational poles would keep the sphere stationary. If an eclipse occurred with the moon passing between the Earth and the Sun, would that disrupt the gravitational equation and make the sphere move, or is gravity a kind of polar or circular force that would just bend around the interloping moon? And does the gravity effect travel at greater than the speed of light?"
Well, first of all, we think that gravity travels at the speed of light. If the sun were to disappear right now the sun were to somehow vanish, we wouldn't feel the effect of this for 8 minutes. It would take 8 minutes for the shock wave of the disappearing sun to finally reach the Earth. Now, Newton thought that gravity was instantaneous, that if the sun were to disappear right now, the Earth would be thrown out of its orbit immediately. Einstein says nothing can go faster than light, so that if the sun were to suddenly disappear, gravity, the gravitational shock wave, the gravity wave, would take about 8 minutes to hit the Earth. Mm-hmm. And to answer your question, between the sun and the Earth, there are what are called Lagrange points. Lagrange was a mathematician around the time of Napoleon, and he showed that if you have a solar system of bodies, there are points where gravity cancels. These are called Lagrange points. And NASA is even thinking of maybe one day sending a probe to the Lagrange points between the Earth and the Moon. The Earth and the Moon system has Lagrange points. And they could collect debris. They're stable. They could collect debris left over from the beginning of the solar system. So your caller is right. There is a Lagrange point between the sun and the Earth. However, if there's an eclipse, it's not going to change anything. The moon is so tiny compared to the sun and the Earth. As the moon moves around the Earth, it'll change the Lagrange point a little bit, but hardly affect it at all. The sun is so massive, even the Earth would appear as a pea compared to the gigantic size of the sun.
So, in other words, if it were a satellite, this sphere he talks about, they might have to make a small adjustment at that point?
Yeah, if there was matter collecting in the Lagrange point between the Earth and the Sun, then, of course, the debris could be moved a little bit by the presence of a satellite. However, I would imagine the Lagrange point between the Sun and the Earth is inside the Sun, so I'm sure nothing could survive being inside the Sun.
Oh, that's a good point. I hadn't thought of that. True. The Sun is so strong that's, I guess, where it would be.
I guess the Lagrange point would be closer toward the Earth. You would have to be very close to the Earth to cancel. The Sun is so massive. The calculation of the Lagrange point would probably put it very close to the Earth instead.
There you are. Okay. We still don't. Do we really fully understand gravity? Do we understand? I mean, it's from mass, right? Or is it?
Well, the other forces of nature, electricity and magnetism that lights up our cities, the nuclear force which lights up the sun, those forces are actually easier to understand. They're quantum forces. We understand them. They're mediated by particles. I got my PhD, and I had to memorize all the names of these goddamn subatomic particles, hundreds of them. We have a good understanding of that. Gravity is the oddball. It's everywhere. It holds us to the floor, but it doesn't behave like the other quantum forces. So to really quantize gravity and make it like light, make it like the nuclear force, you have to introduce an even higher theory, a theory even beyond Einstein. Einstein said that gravity is like the curvature of space and time. But if you try to quantize it and try to make it like the other forces, you have to go to an even higher theory, a theory way beyond Einstein, and that's string theory. So we think that string theory does, in fact, finally give us a description of gravity. Gravity is, like Einstein said, the bending of space and time. But how do you marry it with the other quantum forces? You marry it with the other quantum forces because gravity then becomes a vibration just like all the other forces. So all the forces are nothing but vibrations of the string, including gravity. In fact, if you look at the first octave of the superstring, Einstein's entire theory is part of the first octave of the superstring.
What will the collider do, Professor, to validate string theory, or perhaps not?
Well, it can't validate the entire theory because string theory is a theory of the Big Bang. It's really a theory of the universe itself. To test it directly, you would have to create a baby universe in a laboratory, and that's pretty hard to do. You would have to be almost godlike to create a baby universe in a laboratory. However, you can test the periphery of string theory. You can start to look for dark matter, maybe even dark energy. And these are things that string theory can address. And that's where I think we can test the periphery of string theory with the Large Hadron Collider. We can look for sparticles. We can look for dark matter, all of which are predicted by string theory.
So as it finds these, if it finds these, you'll be jumping up and down.
Oh, yeah. Because, we are talking about, quote, reading God's thoughts. These are Einstein's words. Reading, what was God thinking when the universe was created, right? That's where we're going with this thing.
All right. You've mentioned it so many times. I want to roll over this again. Einstein talked about God a lot. Most scientists, most doctors don't believe in God. Now, when Einstein mentioned God in the way he did, do you believe that he really meant the creator, God, or just the force associated with creation?
Well, first of all, every poll taken of scientists, which has been constant for a half century, shows that about 30% of all scientists are very religious. They go to church every week. They participate in church activities. They're true believers, about 30%. That's held sway ever since we began to poll scientists after World War II. It's been very constant.
But that's still a small number. I mean, that means 70% are not.
No, the other 70%, most of them are agnostic in the sense that, they don't have any opinion one way or the other, maybe, maybe not. And then you have a small core of atheists who actually don't believe in God at all. Most scientists simply don't consider it a scientific question. Now, to answer your question, Einstein believed there were two kinds of gods. One God is the God of prayer, the God of intervention, the God of Isaac and Moses and Jacob, the God that parts the water. He didn't believe in a personal God that you pray to smite the Philistines. He believed in the God of Spinoza, the God of Leibniz, the God of harmony, beauty, simplicity, elegance. The universe is so gorgeous, and it could have been random. The universe could have been ugly. It could have been incomprehensible. But the universe is quite comprehensible. All the laws of physics you could put on 2 sheets of paper. And we even want to get that down to 1 inch. But on 2 sheets of paper, you could put down all the laws of physics, all the laws of the quantum theory, all the laws of Einstein in just 2 sheets of paper. So it didn't have to be like that. It could have been horrible. So Einstein believed there was a God of harmony. And that's the God he believed in. He likened himself as a young child walking into this humongous library, mile-high books and books of books everywhere, and that all we humans could do was open the first page of the first volume of the library. That's how he likened it.
So that was Einstein's belief.
Mm-hmm.
Fascinating. The Royal Society of England, it says here, for the first time in 350 years, just had a conference this week on extraterrestrial life in space. Why? Why the sudden interest in alien life after 350 years?
Yeah, this is generating a lot of news, a lot of press. Is in London right now. Many of my friends are there. Mm-hmm. I'd be there myself, except I've been doing a lot of traveling around the world. But after 350 years, going back to Isaac Newton, in fact, the Royal Society has been ignoring the possibility of extraterrestrial intelligence until this week. It's historic. All of a sudden, people are converging on London, talking about the possibility of flying saucers, aliens, visitation, first contact, SETI, all that stuff they're talking about now at the Royal Society.
Why?
And the catalyst is 2 things are happening. First, Kepler is in orbit now. Kepler is the most advanced satellite specifically designed to find, Pandora, like in Avatar, the movie that you were mentioned, specifically designed to find anything Earth-like in outer space. And on the other hand, we have the Allen Array north of San Francisco. Paul Allen, the Microsoft billionaire, donated around $25 million to create the largest collection of radio telescopes at Hat Creek, north of San Francisco, specifically designed to eavesdrop on the conversations of aliens. That'll increase our power by a factor of 1,000. We can now scan not just a handful of stars, but 1,000 times with more sensitivity. We can now eavesdrop on conversations with alien civilizations. So this is serious business now. 400 planets have now been discovered, all Jupiter-like. But if you saw the movie Avatar, you realize that it wasn't Mars they were talking about. It was a moon of Jupiter. Watch the movie carefully. In the background, there's a Jupiter-like planet. You're on a moon of Jupiter. We think that these Jupiter planets are very plentiful throughout the universe, and these moons can have liquid oceans on them. This is a paradigm shift. We no longer think of Martians as perhaps the paradigm for intelligent life in outer space. We now think of Europa, a moon of Jupiter. And that's what James Cameron did in his movie. He made an explicit reference to Europa, the moon of Jupiter, in that movie. And we think those moons are plentiful, maybe 100 times more plentiful than Mars-like, Earth-like planets.
We see the big ones because they're easier to see.
That's right.
That doesn't mean the smaller ones or the Earth-like ones are not there. It just means we're seeing the bigger ones right now.
Right. In fact, if the Earth were in outer space, we could not detect it. We could not even detect our own Earth because our instruments are too crude to detect these tiny little pebbles called Earth-like rocky planets. But these Jupiters are easy to detect. They have moons. Our Jupiter has scores of moons, and we think that some of them have oceans underneath the ice cover. And the volume of these oceans is larger than the volume of our oceans. These are small moons, but the oceans are quite deep, so deep that the volume is gigantic, even larger than the volume of the oceans on the Earth.
Well, if there is a Pandora out there, and it's even closely depicted properly in that movie, then I didn't see any radio transmitters, any big dishes pointed anywhere. They wouldn't have been generating any RF in any direction at all. They didn't need it. They had a whole different setup. Perhaps when we get back from the break, we can talk about or ask if that would be the likely way it would develop. And therefore, of course,